Good morning, Year 10. You should have completed a task on Heggerty Maths before looking at this video. That was just reminding you what vectors are. I didn't want to go through it too much in the videos because it's something that you've done before, probably I think as long ago as Year 8. So have a look at that video if you haven't already before. And if you have, then what I would like you to do is to describe in as a column vector the vector from A to B, so from here to here, the vector from B to C, and then the vector from A to C. Okay, so pause the video now and just have a go at writing those down. Okay, so first of all, you should have remembered that if we go, in fact, if I write that up at the top here, at the top of our vector, we have the x movement, and at the bottom we have the y movement. Remember that going to the right in the x is positive, and going to the left in the x direction is negative. And then with our y direction, if you go upwards, that is positive, and if you go downwards, that would be negative. So if I'm going from A to B, then first of all, I need to count how I've moved in the x direction. I've run towards the right, so it will be positive, and I have moved 1, 2, 3, 4, 5, 6, 7 to the right, and then 2 up. Some people actually count from A and go 1 on A and then 2, so just remember that it's when you've actually moved 1. So it's 1, then 2, then 3, then 4, then 5, then 6, then 7. That's just a common mistake that some people do. So it should be 7, 2 and not 8, 3 if you have that. Then from B to C, we're going to have to go, first of all, we'll decide whether we're going right or left. So we're going left, so it's going to be negative at the top. And we're moving 1, 2, 3, 4 to the left. And then we're going down, so that's negative as well. 1, 2, 3, 4, 5, 6, 7. So it's -4, -7. Then finally we have the vector from A to C. So we will go 1, 2, 3 to the right, so that's a +3. And then down 1, 2, 3, 4, 5. So it was down, so that will be a -5. I'll just make that bigger. And those should be the answers that you have. Hopefully you didn't find that too tricky, but if you did, just go onto Heggerty Maths and just have a go at those videos again and just make sure that you fully understand how to move or the movement involved with the column vector. Okay, so it's quite important that I just go through the different types of notation with a vector. I'm sorry that this is a little bit pixelated, but you can denote a vector in quite a few different ways. So some people, for example, if this is A here and this is B, some people would call this vector here A to B, and it can be written like that. You might label the vector as well, so they've labelled this vector A. So you could call the vector A, but usually if you do that, then it's A in bold. Sometimes as well, they might put a line over the top of the A to show it's a vector, and sometimes they might show a line under the A to show that it's a vector as well. So there's quite a few different ways that vectors are written, and if you have a look at this in different books or perhaps on different websites, it may look different. Okay, there's a slight difference between using this top notation compared to the others. This is describing the movement from A to B, and it's just the movement from A to B, whereas if you describe a vector as A, all these three essentially mean the same thing. It's just that they're written slightly differently. But this vector could be anywhere, so it could be going 3 to the right and 4 up in any direction, whereas the top one here is specifically going from A to B, but all are pretty much exactly the same thing. Okay, so to pick up what I was just saying there, that a vector is the same no matter where it is. So if we have the vector A here is 2, 3, so you may want to write what that means. It means 2 to the right and 3 up, and you're translating this point P. By that vector, you would go 2 to the right and 3 up, 1, 2, 3, and you would end up there. If you were to do the same thing for Q, you would do the same thing, go 2 to the right and then 3 up, 1, 2, 3, and you end up in the same place. So what you'll notice is that no matter what point you apply the vector to or translate the point by, or no matter what vector you translate the point by, you'll still end up with the same movement. So this here, the vector on P and the vector on Q are the same thing because you have applied the same vector. Okay, it may be that you call this point here R, so we might call this point R and this point S, and then we could call this PR, and we could call this QS because it's going from Q to S, and this one from P to R. But both vectors are A, so they're the same movement, so therefore they're the same vector. It's quite difficult when you're writing with handwriting to try and make something look bold, so that's why quite often they do underline the vector just like that, just to show that it's a vector and not a number. Okay, so we're just moving on to vector addition now. So here it says, draw a diagram to show the resultant vector of A plus B. So you can think of this as if you have a point and then you apply two translations to that point. So first of all, let's say the point is here, and I first of all apply the vector A to translate it. So that means I would go 2 to the right and 4 up, and I would end up there. So that there is the vector A. And make sure as well we're just putting the arrow in the direction that we're travelling. If we were travelling in the other direction, then it would be that we were going 2 to the left, so -2, and then 4 down, and then -4. But we'll come back to that a little bit later on. Then after that, we're translating the point again by the vector B, which is 5 minus 1. So that's 5 to the right, 1, 2, 3, 4, 5, and then 1 down. So we would end up there. So to move this point to this point, that would be the vector B. So when it says here, find the column vector of the resultant vector, that just means how far have I actually moved, or by what vector have I actually moved. So you might notice that if I go up here and follow the path of A, and then across here to B, or follow the path of B, then there was a far quicker way that I could have gone. So I could have just gone straight from here to here. So to save me a bit of time, I could have gone this way. So the resultant vector would be the quickest way that you could have got there. So in this example, it would be 1, 2, 3, 4, 5, 6, 7 to the right, and then 1, 2, 3 up. So the resultant vector would just be the quickest way that you could have got there. What's important to note as well is that a vector is measuring displacement, which is different to distance. So distance would be how far you've travelled, whereas displacement would be how far have you moved from the original place that you were. So how far have you moved from here to here. So what you might notice is that we called this A plus B, and A was 2, 4, B was 5 minus 1, and what you may notice is actually that we've just added them together, and all that you do when you add vectors is add the top number, so the horizontal movement, to the top number, so 2 add 5 is 7, and then the bottom number to the bottom number, so 4 add -1 is 3, so 4 add -1 would be 3, because when you add a negative number, it's the same as taking away 1, so 4 add -1 is 3. So when you add a vector, all that you're doing is adding the top number to the top number and the bottom number to the bottom number, but obviously that's not as mathematical for me to say that. I'm not actually going to ask you to draw these out because I know that you can all translate points and it's fairly easy and it's just a matter of counting. So we're going to move straight on to just using the vectors without actually drawing them like we have done here. Okay, so this is just a slightly more formal way of writing what I just said. So if you have the vector AB and you add the vector CD, then the horizontal movements are A and C, so you would add together the A value and the C value, and then the vertical values are B and D, so you would add those two together to get that there. So that's just a more formal algebraic way of writing it. You may want to pause the video and just have a go at these questions here that I'm going to do as an example, but I think you'll find them relatively easy. So if the vector A is 4, 7, and the vector B is 3 minus 5, then I just add the horizontal movement, so 4 add 3 is 7, and 7 add -5 is 2. So A plus B would be 7, 2. On to the next one, so B is 3 minus 5, C is 0, 4. So first of all, we start off with the horizontal movement, so 3 add 0 is 3, -5 add 4 is -1. On to C. So A was 4, 7. C was 0, 4. So we can do 4 add 0 is 4. 7 add 4 is 11. And those are just the resultant vectors for each one. So it's fairly easy. Okay, so hopefully this isn't too difficult and you should be able to do this straight away. So I would like you to have a go at these questions here whilst pausing the video, and then in a moment just have a look and check that you've got them right. If you do find it fairly easy and you pretty much get what you're doing, you may just want to start from E and do the questions on the bottom row. H I've put a star by because actually this part here where it says 2A, you may need to think about it a little bit more. Okay, so pause the video and have a go at these now. Okay, so these are the answers to those questions. I'm just going to show you H here. What you could do is you could think of 2A. This just works exactly the same as algebra. So 2A is the same as A plus A. So you could think of it as A plus B. There is another way you could do this as well. And then A was 3, 0. So it's 3, 0, add 3, 0. Add B, which is 2, 7. And then you can just add the top ones. So 3 add 3 add 2. So that's going to be 8. And 0 add 7 is going to give us 7. So you could do that, but there is a different way that you could do it as well. So if you've got 8, 7 in a different way, then that's brilliant. Okay, so I'm just slightly picking up on that point that I just said there. So if I have the vector r is 3, 4, and I wanted to find r plus r, then I could start off, say, here, and apply the vector 3, 4. I'm just going to use a different colour there, actually. So 3, 4 means go 3 to the right and 4 up. 1, 2, 3, 4. And then I'm applying the same vector again. So I'm going to go 3 to the right and 4 up. 1, 2, 3, 4. And what you may realise is that the total vector, so we said that this was r, and I applied r again. If I wanted to find the total vector, let's do that in blue, I would have gone 1, 2, 3, 4, 5, 6 to the right. And then 1, 2, 3, 4, 5, 6, 7, 8 up. And what you may notice is that actually all that's happened is that I have doubled the top number. So I've doubled the 3 to get 6, and I've doubled the 4 to get 8 there. So r plus r is the same as 2r there. So what I could have done is, rather than, I could have either added those together, 3, 4, add 3, 4 is equal to 6, 8. Or I could have just said 2 times by 3, 4. So when you multiply a vector here, so 3, 4, by this is what we would call a scalar, it's just a number. Then we do 2 times 3 is 6, and 2 times 4 is 8, and you would get the same answer. So here it doesn't really matter whether you use this top method or this method here, but on the bottom one, it would probably be a lot easier if I were to, I could apply this vector again, so 1, 2, 3, and then 1, 2, 3, 4, so I'm here. And then I could count how far I've got to go across. And so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 across, and then it's going to be 12 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I could have done that, so I know that that is going to be 9, 12. But a far quicker way is to say that r plus r plus r is the same as 3r. So I could have just done 3 times by r, which was 3, 4. 3 times 3 is 9, and 3 times 4 is 12. So it's actually very, very easy to multiply a vector by a scalar. So, for example, if you have r, it could be easy to find 2r, 3r, 4r, 10r. You could even times by, say, 3 over 2r. So you can times it by a fraction, any number that you could think of. Okay, so again, this is a more formal way of saying it. So there is an example here of 4 times by the vector 3 minus 2. So we did 4 times 3 is 12, and 4 times minus 2 is minus 8. And generally, you could say that whatever you multiply it by, so if you had the vector AB and you multiplied it by k, the horizontal movement would be ka, and the vertical movement would be kb here. So I'd like you to pause the video now and have a go at these 4 questions here. Okay, so I don't really think I need to go through all of these. So the answers are just there. So please let me know if you've found that difficult or you've had any problems with that. If I just quickly have a look at D, which was minus 4t, you may find this a little bit more difficult because, let's just make t bold there. So if I did minus 4 times by minus 2, 5, It's possible that you may have got -8 here. Just remember that if it's -4 times by -2, that's going to give you a +8, and -4 times by +5, which is just going to give you -20. Okay, so I'd just like you to put, for the last exercise today, just put those skills together and see if you can have a go at these questions just here. So pause the video now and see if you can attempt these questions. Okay, so these are the answers to those 4 vectors there. Or 4 questions, sorry. So all you have to do first of all, so the first step is just to substitute the vectors in there. Just remember as well that you must multiply before you add, so you must do 3 times c to get 312 here before you add those 2 vectors, okay? Otherwise, it's just the same as BIDMAS, but with vectors instead. Otherwise, if you were to add them first, it would be written like this instead, okay? So make sure that you're following the rules of BIDMAS, even though it's vectors as well. So hopefully you found these relatively easy. If you wanted to do more practice, I got quite a lot of these questions today from Corbett Maths. So go into Corbett Maths, have a go at these questions, and then see if you fully understand this, okay? If you found this incredibly easy today, that's brilliant. And the reason that I've gone relatively slowly is just because we will be doing algebraic vectors after this, and it's really important that you fully understand how numerical vectors work before we go on to algebraic vectors, which you will study next week. Okay, so hopefully you understand this. If not, please leave me a comment on Show My Homework, and I'll see you again soon. Thank you.